This is Mrs. Fraser, and we are going to look at how to solve systems of equations using substitution. So we've spent the last couple of days exploring this, and now we are going to look at the algebra side of solving a system of linear equations with substitution. So the first thing you want to ask is one equation solved for one of the variables? Because substitution cannot happen unless you know what one of the variables equals. So if the answer is no, like you can see from our systems of equations that are located here, then I have to solve an equation for one variable in terms of the other. So I'm going to pick the equation that's going to be the easiest, which would be 2a minus b equals negative 3. Because there's no coefficient to b, so I won't have to do any dividing. So I'm going to solve for b by subtracting 2a from both sides. And then I am going to multiply the whole equation by -1 because I can't have a negative b. So now I'll have b equals 3 plus 2a. And I'm going to circle my isolated variable of b. So now I'm going to substitute this expression of 3 plus 2a into my other equation that I have not used yet, so that I can now solve for a. So I'm going to take 3a minus and then 2, and now instead of writing b, I know b is actually 3 plus 2a. So I will substitute 3 plus 2a into its place. So 3a minus 2 times 3 plus 2a equals 13. So now I'll just take this equation and simplify it. So just to rewrite it, to simplify, I'm just going to solve. So I'm going to start by my distributive property, taking my term from the outside, multiplying it by everything on the inside. So 3a minus 6 minus 4a equals 13. Then I'll combine like terms, which leaves me with negative a minus 6 equals 13. And then I'll add 6 to both sides, which leaves me with negative a equals 19. To get rid of that negative a, I'm going to divide both sides by -1, or you can multiply by -1. And I'd end up with a equals negative 19. So now that I know my a value, I can actually take my a value and plug that back in. I can substitute this back into this other equation that I solved for b for. Now I don't want to substitute in for b. Let me make that more clear. I want to substitute in for a in this case. So I'm going to rewrite that equation. B equals 3 plus 2a. Oops. And now I'm going to substitute in for a so that I can find what b equals. So b equals 3 plus 2 times negative 19. I'm going to simplify that equation from above and solve. So 2 times negative 19 is negative 38. Don't mess up your order of operations. We have to multiply before we add. 3 minus 38 is negative 35. So b equals negative 35. So now I know a equals negative 19 and b equals negative 35. I can write this as a coordinate of negative 19 and negative 35. I can also check my solution, and I think that's really important to do. So I could actually use negative 19 and negative 35 back in both of my equations. So in my calculator, I could actually substitute in negative 19 for A and negative 35 for B into both my equations, and it should tell me true in my calculator. Or if you don't want to type in with the equal sign, you could just type in the expression and see, do you get negative 3? If you do, then you've done it correctly, as long as you also get 13 here. So you need both to be true in order for the system of equations to actually work. If it's not true for both, somewhere you've made a mistake. So your job now is to go ahead and complete your systems of equations loop. The key will be posted to Canvas, so you can check that as you go. Please let your teacher know if you have any other additional questions about systems of equations.